So, good afternoon, dear students. We'll start with the unit number 4 of electrical machine design. And in this unit, we will be discussing the design of three-phase induction motors. So, induction motors, you all know what is induction motors. Induction motors are basically AC motors, which convert AC supply into mechanical output. AC motors are also known as asynchronous motor, and they are basically based on the law of electromagnetic induction, Faraday's law of electromagnetic induction. So induction motors are rotating machines which majorly have two parts like stator and rotor, similar to DC machines or any other rotating machine. The stator part is the stationary part which encloses the various other assemblies of the motor, and rotor part is the rotating part which rotates because of the Faraday's law of electromagnetic induction and produces the mechanical output. So in this unit we will discuss the design of these machines. So the syllabus content of this particular unit is given here. So general considerations, output equation, choice of specific electrical magnetic loadings, number of slots in stator and rotor, elimination of harmonic torques, design of stator and rotor windings, leakage reactance, equivalent resistors, coil cage, rotor, and magnetizing current and temperature rise and efficiency. So start with induction motors are the AC motors which are employed as the prime movers in most of the industry. So AC motors finds their application primarily in the industries, specifically three-phase induction motors. Your fan basically which you use domestically, the motor of a cooler, they are also AC motors, but they are single-phase induction motors. Now why do we call them induction motor? Because of the reason that they work on the principle of electromagnetic induction, but also now DC motor also works on the principle of electromagnetic induction. All the rotating machines work on the principle of electromagnetic induction only, but induction motors or asynchronous motors basically, which are three-phase induction motors basically, their principle is a bit different. The way the EMF or the current is produced in the rotor of the motor is different as that is the case of a DC motor. In DC motor, what we do is we give current to the armature of the motor, means the rotating part, the rotor basically. And as per the principle that when a current carrying conductor is placed in magnetic field, the conductor experiences torque. And based on this principle, every motor works, means there has to be a current carrying conductor, there has to be a magnetic field. So because of the interaction of the current, the magnetic field produced by the current in the conductor and the external magnetic field wherein the conductor is placed, they both when interact, so a force is experienced by the conductor. We call this force as torque. So all motors work on this principle, right? So induction motors are majorly used nowadays, and DC motors are becoming obsolete. The reason being is that AC motors nowadays, which are being developed and manufactured, have rugged design and good efficiency, and they have other benefits also over the DC machines. And the primary benefit is that they work on AC, which is primarily uh, you know available to us. So now these AC motors are widely used, means these induction motors basically. Now why do we call them asynchronous motor? That is again concept to understand. So such motors are widely used in industrial applications, from small workshops to large industries. See, you will find the use of induction motor in almost every industry, from single phase induction motor through to three phase induction motors. All are used in almost every industry. Okay, even your tulu pump basically, which is used to extract water, or the submersible motor, they are also induction motors. They may be generally tulu pump is single phase induction motor, and submersible motor can be single phase or three phase, right? So these motors are employed in applications such as centrifugal pumps, conveyors, compressor, crushers, and drilling machines, etc. So these basically motor is a rotating machine, and it provides a rotation. So the rotation is used in various to perform various tasks basically, and that become the application of that particular motor. So in stamping dies, and in cranes, and in drilling machines, lathe machines, so all these applications basically make use of AC motors. In conveyors also, so conveyor or bottling plant, or filling plant basically, or where, like if you talk about cement industry, where the cement is uh, made and that is filled into the bags. So conveyor belts are used to carry the bags basically, and then somehow the cement is filled into the bags, and then the bag is sealed, and then it is taken away through conveyor belt only to the other side for loading purpose, right? So because of their various advantages over DC machines, three phase induction motors or single phase induction motors are used in industries. Now the constructional details. Similar to DC machines, an induction motor consists of a stationary member called a stator. So the major parts of any rotating machine are two. One is the stator, which is the outer part, which gives an enclosure to the various motor assemblies, which gives a protection also to the motor parts, basically sophisticated motor parts. And because this part, the outer enclosure, is stationary, static, so we call it stator. And the second major part of the machine is rotor, or rotating member, right? So in DC machine we call the rotating member as armature, and in AC machines it can be armature, it can be field system, right? Yes, we may have a static field system, stationary field system, we may have rotating field system, or we may have stationary armature, or we may have rotating armature in AC machines, right? Now induction motor is quite different from DC machine on the basis of following uh, factors, like laminated stator. The stator of AC machine is laminated. Now why it is laminated? Because see, in DC machine, if you compare an AC machine, specifically induction motor, with a DC motor, a DC motor has static magnetic field system. Okay, so if we draw the diagram of DC machine, let us say this is a rotor, and rotor has some slots over it. Okay, it has some slots over it. So these slots are used to put conductors on it, and then conductors are conductor means winding, the armature winding basically, and then armature winding is connected uh, in certain formations, wave formation or lap formation, and this center part is, let us say, the space for shaft, and then we have the outer stator part. Or stator part has pole shoes basically mounted into it from inside the wall of the stator, right? So you have pole shoes, like this is a 4-pole machine which I have drawn here. So the windings are wound over the each pole, and the windings are connected either in series or shunt with the armature or separately excited DC machine we have. So the supply which is provided to the winding, field winding basically, these are the field windings which are on the pole shoes. So the supply which is provided is DC. So this DC supply produces a DC flux, means static flux. Okay, so then we have armature and we have current carrying conductor within the field, and then it rotates, right? Now in induction motors, we make use of laminated stator because the way winding is put on the stator. The winding on the stator can be the armature winding, or it can be field winding also, depends upon which kind of AC machine we are using, right? So laminated stators are used for various reasons, and to reduce the losses because of eddy currents and all that. So and also to provide insulation basically, because winding is put on the stator internally, right? So to avoid any kind of short circuiting or hazardous mishappening, or any kind of mishappening, sorry. So laminations are used in stator also. The absence of commutator, we don't have commutator in AC machines. In DC machines we have commutator. The purpose of commutator is basically to convert the bidirectional supply into unidirectional supply in case of DC generators, and vice versa is the case of DC motors, means unidirectional input to the bidirectional supply to the armature, right? Okay, so uniform and small air gap, so to make the maximum utilization of the flux or field within the air gap, so a uniform and small air gap is kept, right? Because three-phase induction motors are self-starting motor, and we all know that they are self-starting because of the reason that the flux within the air gap of three-phase induction motor is rotating is of rotating nature, basic, right? So practically almost constant speed, and so this is also one. So that means we may have some fluctuations of speed in DC machine, but in AC machines it is quite constant. The AC induction motor comprises of two electromagnetic parts. So again the same thing is repeated. So both are electromagnetic here. Okay, both are electromagnetic here, stator as well as rotor, because like DC motor, here also we have winding on stator as well as on rotor. In DC motor also we have winding on stator as well as on rotor, right? Now stator and rotor are each made up of an electric circuit. So we have an electric circuit on stator. We have a magnetic circuit on stator as well as on rotor. So that means both stator as well as rotor can be used as sorry can be used as an electric circuit as well as a magnetic circuit, right? So the electric circuit is basically made up of insulated copper or aluminum winding to carry the current. So since we have winding on the stator also and it carries current, so it is an electric circuit. And magnetic circuit usually made up of laminated silicon steels to carry the magnetic flux. So basically flux needs to be conducted. So in both cases, okay, rotor as well as stator, right? The stator is the outer stationary part of the motor, which consists of the outer cylindrical frame. This is what we have discussed, that the outer frame is stationary. It is used to provide enclosure to the certain motor parts, sophisticated motor parts, and also it protects the various motor parts from any external impact, right? So the outer frame is known as yoke. It is also known as yoke, right? And it is basically made up of sheet steel, cast iron, or cast aluminum alloy, right? Okay, so just so as to uh, conduct maximum flux, right? Okay, so the magnetic path, another part of stator is the magnetic path, which comprises a set of slotted steel laminations called stator core pressed into cylindrical space inside the outer frame. The magnetic path is laminated to reduce eddy currents, reducing losses and heating. So magnetic path here means that the path followed by the flux within the machine, right? So okay, so apart from the these two, the outer cylindrical frame and magnetic path, the stator has few more parts included: a set of insulated electrical windings which are placed inside the slots of the laminated stator. Now you can see here this diagram which you see, this one, it has two parts. This outer part, this belongs to stator, and you can see this inner sheet with slots, it belongs to rotor basically. Okay, so this belongs to rotor, this belongs to rotor, and the outer one belongs to stator, right? So so now you can see, this is what we were discussing, that the stator of an induction machine, it is laminated, it has laminated sheets. Now why it has laminated sheet? You can see that thin sheets of cast iron or steel are formed in this way, like this. So here you can see these are the slots. We call them stator slots, right? These one, where the stator winding is kept. Here the stator winding is kept, right? And you can see that the thin sheets in this formation, there are a number of thin sheets in this formation. They all are stacked together. To form the stator. Now the stator laminations are shown here. This is the real picture of stator lamination. You can see this one. So this stator part, this one, it is made up of various thin sheet of similar formation, and they all are stacked. You can see these all are stacked together to get an assembled stator basically, and windings are kept in these slots here, stator winding basically, right? So this hole is used for shaft. Okay, and this whole thing, this part, this one, this is the laminated thin sheets for rotor. So rotor is formed using laminated thin sheets of this formation, and the windings are kept, the rotor winding, this one, are kept here in these slots here. So these are known as rotor slots, and this is known as rotor laminations, means laminated thin sheets, right? So the cross-sectional area of these windings must be larger enough for the power rating of the motor, the cross-sectional area. Now you can also see that this part is the status part, and this belongs to the rotor. Now you can see between the stator and rotor you have a very small air gap. You can see here this one and this one. It's very small air gap between rotor and stator, and the generally it is generally this gap, basically the air gap between rotor and stator, is kept uniform, right? For a three-phase motor, three sets of windings are required, one for each phase connected in either star or delta. So this is obvious that for a three-phase winding, you need for a three-phase motor, you need a three-phase winding. Okay, for each phase there has to be one set of winding, right? Okay, so now the rotor part, basically. Now you can see here this one. This is the stator, the outer, this one. This outer part is basically known as yoke. This is known as yoke, or you can say outer cylindrical frame. Okay, within this frame you can see you have this winding. This winding is basically the field. Either this is a field system or this is armature, right? So you have the slots, armatures, sorry, rotor slots here, and you have the windings placed in these slots like this. Windings are placed in these slots, right? Okay, and windings are connected in some formation to supply the AC signal, right? Now you can see here in this particular figure, you can see the yoke is smooth. Yoke means this outer frame, it is smooth. You can see it is totally smooth. And in this case, it is again a three-phase induction motor here, this one. And here the frame is ribbed yoke. Ribbed means it has some fins connected on the external part of the motor, means the yoke part, right, or outer frame. Okay, so now let us come to rotor. Rotor is the rotating part of induction motor. The rotor also consists of a set of slotted silicon steel laminations pressed together to form of a cylindrical magnetic circuit and the electrical circuit. What does it mean? It means that thin laminated sheets are made in this way, and here this one which you see, this one, these are the slots of rotor here. Okay, so thin sheet of this formation are made. This is for shaft. A number of thin sheets are made. They are laminated individually, and then they are pressed together. They are stacked together to form a block of rotor, right? Okay, and again, since rotor is made up of ferromagnetic material, so it provides the magnetic path to the magnetic flux, means it conducts flux, so it behaves as magnetic circuit. And also the windings which are placed into the rotor slots are made up of the metal or conductor material, so, and carrying current basically, so they behave as the electrical circuits, right? So basically induction motor is three-phase induction motor. It is basically categorized on the basis of the formation of rotor. If the rotor is of squirrel cage type, so we call such AC motor as squirrel cage induction motor. If the rotor is wound rotor type, so we call such machine as wound rotor induction motor, right? Wound rotor induction motor is also known as slip ring induction motor, right? Okay, so squirrel cage rotor consists of a set of copper or aluminum bars installed into the slots. So instead of having the winding, okay, winding wires basically, so copper or aluminum bars are used and they are put into the slots. You can see these are slots here. Okay, these parts are slots basically, where either copper or aluminum bars are kept, and they are basically connected to one another. You can see all the windings, this to this and this to this here, all the windings are short. All the windings, all the conductor bars are short with the help of this plate, this one, right? Okay, so which are connected to an end ring at each end of the rotor. And so this external part is basically the end ring. This one is end ring, right? And it is used to connect every, you can see all the conductor bars are connected to one another, right? So these are short, right? You must have studied it in electrical machine. So so this particular motor is not squirrel cage motor because its formation resembles the squirrel cage, right? Then aluminum rotor bars are also used basically. Okay, so aluminum using see aluminum has certain advantages over copper in terms of the uh, price. Okay, so the motors made up of the bars, basically the conductor bars which are made up of aluminum, so such motors are uh, quite cost effective as compared to the motors which make use of copper, right? Okay, and also using aluminum, so aluminum is lightweight actually. So the use of aluminum make the overall weight of the motor less. Okay, so it results in lightweight AC motors as compared to copper, right? So even though the aluminum bars are in direct contact with the steel laminations, practically all the rotor current flows through the aluminum bar node in the laminate. So you can see the conductor bars here, like this one. It is in contact with the laminations. These are laminated sheets basically. So this is also working as the end rings. Okay, fine. Now you can see the lamination insists this formation. The formation of lamination is same which I just discussed in this way. The thin sheets are made in this lamination, right? This one, like this, for example. Okay, so this is for shaft, right? And the aluminum bars or copper bars are kept here. They are kept here. Now what is done, basically they are welded to the rings, or you can say they are welded to the laminations, right? They are welded here. Okay, and from the other end also they are welded, right? So though there is a connection, there is a metallic contact between the aluminum and the ferromagnetic material, means this one, but still the current will keep on flowing in the bars only. The current will not go into the ferromagnetic material, right? So this is squirrel cage, and it is quite skewed. Basically, you can see the space for conductor bars. You can see it is skewed, and this is purposefully done to have the impact of or have the maximum interaction of the conductor bars with the magnetic flux, right? Have the maximum interaction, right? Then you have wound rotor type induction motor. So wound rotor consists of three sets of insulated windings which are with connections brought out to the three slip rings mounted on one end of the shaft. So you can see, so here also it is quite skewed. The bars are skewed. Here you don't have conductor bars placed. You have specifically bunch of copper wires formed in some formation and kept in these slots here, right? And then windings are connected to slip rings here. Okay, the windings are connected to slip rings, so that when these slip rings are connected to external brushes, the supply from the external point can be brought into the armature through brushes and these slip rings. These are slip rings, right? Okay, now this is the equivalent circuit of a slip ring motor. Okay, so here you have rotor winding and slip rings. So rotor winding is connected to slip in these black points with these one. These are the carbon brushes. and then it is connected here, right? Okay, so the external connection to the rotor are made through brushes into the slip. This is what I just said. So because slip rings are present in this type of motor, so we call this as slip ring motors, right? Now other parts of an induction machine are, apart from stator and rotor, are basically the bearings, shaft, cooling fan which is used to exhaust the heat generated within the machine, and two end flanges to support the two bearings. Okay, so this is the cut set view of an induction machine. You can see, so in this you can see this one is the shaft, and then this is the rotor part, or basically uh, the conductor bars are placed over it in the slots, and you can see this one, this external, this one, this is the windings over the stator, this one, and here you have given the supply, you can see. Okay, so the supply is given here, right, and it is for the external circuitry. So fan is used at the end here. Here the fan, exhaust fan is used to exhaust the heat from the motor. So let us come to the design. So before that, we must know how a three-phase induction motor works and why it is a self-starting motor. So because in three-phase induction motor, the three-phase flux is generated, and the nature of this three-phase flux is rotating nature. So this rotating flux, what it does is, this rotating flux, so it rotates in basically, sorry, right? So it rotates, and when this flux interacts with, when this flux interacts with the conductors, in the conductors, and these conductors are connected back to back, these conductors which are placed into the slots, they are connected to one another. Okay, so what actually is happening in three-phase induction motor, you have a rotating flux, you have stationary conductor, for example. So this rotating flux is cutting the stationary conductors. So after some time, due to the Faraday's law of electromagnetic induction, these conductors will have some EMF induced over them. And since these conductors are back-to-back connected, circuit is formed. So this induced EMF will result in the flow of current in the conductor bars. So now you have current carrying conductor placed in magnetic field. So once you have current carrying conductor placed in magnetic field, so this rotor, which is having conductors over its periphery, will start rotating. Okay. So why do we call it as, now see, unlike DC motor, in DC motor we purposefully provide current to the rotor and then it rotates. But here we have not provided any current to the rotor. It is all because of the rotational nature of the field. You have got some current flowing in the conductor bars of the rotor. So the current you have got is because of induction principle, right? And that is why we call it as induction machine. Now why do we call it as asynchronous machine? Because the speed at which flux rotates within the air gap in a three-phase induction motor, and the speed at which rotor rotates. So let us say ns. Ns is the speed of the flux, which we call as synchronous speed, and nr is the speed of the rotor, right? So these two are generally not equal, where ns is greater than nr. Ns is greater than nr, right? So this is what because of which the rotor keeps on rotating in three-phase induction motor, right? So if ns becomes equal to nr, so in that case the induction principle will not work, and you do not have any rotation of the rotor in case of three-phase induction motor, right? So if we now, this is the introduction of the three-phase induction machine. Tomorrow we will discuss about the design of and the output equation. So these two things are left. So we'll discuss the design and the output equation and specific electrical and magnetic loading of an induction motor. Right. So this is it for today's lecture, guys. So if you have any question,
Thank you,
any
sir.
query, you can ask. Any query, bacha?
No, sir.
Okay, then thank you so much.
Thank you, sir.
Thank you, sir.